All right, good morning, everybody. Hopefully, everybody is not too sleepy. We are still continuing on with more geometry. Not many numbers, but a boatload of words. You are definitely going to want your books open for today's Socrative quiz. Welcome to lesson 32, all about polygons. So, we're going to start off here. A plane in geometry is not a flying contraption. It's a flat surface that extends without end. You got to think of it as a wall that goes on for infinity in all directions. Can you picture that in your mind? That is a plane in geometry world. And they want you to know that planes can contain flat two-dimensional shapes such as triangles, squares, circles, etc. And some of these shapes are called polygons. Let's see what else we know about polygons. A polygon is a flat shape formed by line segments. To be a polygon, it has to be made up of line segments that close in an area. A few more things to know. The line segments that form a polygon, they're called sides. And a polygon can have three or more straight sides. Two sides meet at a vertex, which is a fancy word that means the corner, to form an angle. And we talked about angles yesterday, right? And the plural of vertex is kind of tricky. It's called vertices. You have one vertex or one corner. If I'm talking about more than one of them, I could have four vertices. The vertices are the corners, the angles. The sides are the lines. So a polygon may have three or more straight sides, and it always has as many vertices or corners and angles as it has sides. If you got a triangle with three sides, you're also going to have three vertices. If you have a pentagon with five sides, you're going to have five vertices, etc. And a really big one here, polygons do not have curved sides. So you're definitely going to want to have your book opened up because there is a chart between pages 198 and 201, and you're going to have to be able to retrieve these names. I don't expect you to have them memorized, but I expect you to be able to open up a book and turn back and look whenever we need. So some of them are pretty easy. We all know triangles since kindergarten. But quadrilaterals, the four-sided shapes, you might call them squares or diamonds or even that guy. All we need to know, any polygon with four sides is considered to be a quadrilateral. That word quad means four. A pentagon has five sides. That prefix penta means five. Hexagon is any six-sided shape. It doesn't have to look like this, but it does have to have six sides. A heptagon is any polygon with seven sides and seven vertices. You got an octagon. That prefix octa always means eight. You got deca. Remember this prefix? That always means 10. Decagon. And for the really complicated, we now have dodecagons. Those have 12 sides, 12 vertices. I would almost recommend hitting stop right now and just reading and absorbing these before you go on. You definitely are going to have to be responsible for having all of these to answer your Socrative quiz. So let's jump right into it then. It's starting off with something like this. Which of these shapes is not a quadrilateral? Did you remember what a quadrilateral was? That was any polygon that had four sides. Well, the square has four sides, and this diamond-looking guy, which we call a parallelogram, he has four. Even this weird triangle-looking thing, if I count it, that truly has four sides, doesn't he? So the one that doesn't have four sides is figure C. Take a look here. Which of these shapes is not a polygon and why? If you remember the big one here, polygons do not have curved sides. So which one is not a polygon? That would be figure D here. And if you had to go and truly tell why, what would you be able to say? I would go ahead and just say polygons don't have curved sides. As simple as that, right? Let's keep moving on. Which of these shapes is not a polygon and why? If you go back to remembering here, a polygon is a flat shape formed by line segments that close in an area. They have to be closed. So let's go and take a look at what we got going on here. Which of these guys is not a polygon? Did you get it figured out? It's gonna be figure B. And did you figure out why? Because we would have to say polygons have to be closed. And that guy is open right here, right? Okay, let's keep moving on. Name each of these polygons. Now, again, I don't expect you to have them memorized. And I don't expect you to look in your book and see any of these shapes. You're not going to see a letter L or a letter E or a letter T. But that doesn't matter. Everybody here can count, right? There's one side, two sides, three sides, four sides, five sides, six sides, right? If that is a six-sided shape and you looked in your handy-dandy chart, that is a hexagon. Let's go and try another one here. Let's just count the sides. One side, two sides, three, four, five, six, seven, 8, 9, 10, 11, 12. Do you remember what that 12-sided shape was? If it had 12 sides, it's called a dodecagon, right? So let's just go ahead and type that in or write that in. Your case, that is a dodecagon. And our last one over here, let's go and count the number of sides again. I got 1, 2, 3, 4, 5, 6, 7, 8. Even though it doesn't look like the octagon that's in your book, that doesn't matter. It's not about how it looks. It's about the number of sides, angles, and vertices it has. All right, are we ready to move on to something else? Let's take a look here, also between pages 198 and 201 of your book. Here's a concept. Polygons that are the same shape and the same size are said to be congruent. If it has the same shape and the same size, this is the word to call it that, congruent. And I was always bad at this as a kid because I have no spatial skills. I would highly recommend turning your book around, really looking at it, because I'm trying to throw you right now. Do you think these two guys here are congruent or not? Well, it all kind of depends on what angle you're looking at, because now they look the same shape, and I assure you they are exactly the same size. Don't be confused just because somebody tries to put them at a different angle. It's your job to spin around the book and make the call, and they are purposely going to try to trip you up sometimes. So, polygons that are the same shape but not the same size, they're said to be similar. So, these guys are definitely the same shape, I see it, but no, they definitely are not the same size. They are not congruent, but they are similar. So you might see some stuff here. Which two rectangles below are congruent? That they would be exactly the same shape and exactly the same size. In this case, it's going to be triangle A is congruent with triangle C. If you don't believe me, you could spin this guy around and he's going to fit exactly perfect on top of triangle A. Which of these two are similar? Well, this guy has a right angle on it. None of these do. They all have acute angles, so it also must be triangle A is similar to triangle C. And we might run into stuff like this every single day for about the rest of your life in 5th grade. So you definitely want to pay attention. Draw a triangle. Everybody knows how to draw triangles, but with a pair, we talked about this the other day. How many in a pair? There's two. Perpendicular. That was also talked about yesterday. And sides. Sides are just your line segment. So I gotta make a triangle. And two of the lines I use have to touch and form a right angle. So if you went in your book because you can't remember what perpendicular is and you see a picture like that, are you going to be able to make a triangle out of this? No, it just means that they touch and form a right angle. So there's one line segment. There is your other line segment, making about as good of a right angle as we can. And then just connect the other two sides so it forms a triangle. Let's try this one. Draw a quadrilateral. How many sides in a quadrilateral? That's 4 with one pair. That's going to be 2 parallel sides. Parallel means that they will never ever touch, right? So, and 2 in a pair. So let's start off with our pair of parallel sides. Now, it just wanted one pair of parallel sides. So do you see what I did here? I made one of the lines a little bit longer so it wouldn't be 2 pairs of parallel sides. This pair and this pair are definitely not parallel. This guy's kind of off on an angle, but the top and the bottom line segment could be considered parallel, right? Little bit of a thinker. My artists out there, this is your time to shine. Let's try this one. Draw a quadrilateral with 2 pairs of parallel sides. So now when I make my parallel lines, I want to go and make them exactly the same length. So there's one pair of parallel lines, and close it out. There's my other pair of parallel lines, right? It's a quadrilateral with two pairs. Think about two pairs of socks, two pairs of parallel sides. Again, draw a quadrilateral, and this throws kids no pairs of parallel sides. Absolutely none. So you don't want to have anything too straight. There would be one side. Whatever I do, I can't make anything parallel. So that looks pretty good there. So these two guys are not parallel at all, right? And if you're not sure if it was parallel or not, maybe I'll make it a little more extreme here. That definitely doesn't look parallel, right? Let's go on and try another one then. So this side, and lastly, this side cannot be parallel either. I have a quadrilateral, a four-sided shape that has no pairs of parallel sides. If you are not watching this or fast forwarding through it, you are going to be really sad and really frustrated. So you definitely want to go and make sure you are paying attention. All right, that is the end. I see no reason for a piece of paper for the Socrative quiz, but you are so going to want your book opened up between pages 198 and 201. Good luck.